If you had to choose one piece of advice for founders in the built world, what would that be?
Yeah, just to compress that feedback cycle, to figure out who your customers are and, be, totally radically prioritized to solving their problem. And, sometimes you have to do things that don't feel like they're going to scale in hardware. And I think lean into that, embrace that.
Why is it a health map? How should I think about the unique value proposition of Gecko?
So instead of one sensor with a human that's taking a reading, trying to interpret that signal in real time, translate that into something like maybe the thickness of the steel, or did they see some kind of anomaly in the signal and that would be indicative of maybe a crack or some other kind of void. We're capturing, 50 readings per sensor every second, having a plurality of 32 sensors on a robot. So you're talking data scale of maybe 10,000 readings over a week versus 10 million readings in a day.
Hey, hi, Troy. Nice to see you.
Great to see you, Gabriele.
Well, I've said this multiple times, been recording a bunch of these episodes of this BitBuilder series. But I always would love to go out and introduce the guests, but I'd like you to introduce yourself better because I think you can do it much better than me. So, please, you can take it off.
Yeah, absolutely. Well, thanks again for having me. My name's Troy Demmer. I based in Pittsburgh, Pennsylvania. Grew up originally on the East Coast, New Jersey, but school brought me out this way. We'll kind of probably circle back on that with where I met Jake Lucerian, my co-founder. But prior to Gecko, in between undergrad and Gecko, which was about a 5-year gap for me, I went into the healthcare space. What I think is interesting about the healthcare industry for me and why I chose that kind of vertical to go in right after my undergrad was really around how to fix what felt like a fairly broken system to me. Something that undergirded society. It's something we really all rely on is our health. And so I had a great experience with a company called University of Pittsburgh Medical Center as an integrated delivery finance system. And what that meant is there was the provider side, the insurer side. And so you really got to see the holistic kind of continuum of care. There's plenty more we could dive into there, but I think it led well into Gecko in terms of, seeing an industry that went through sort of a digital transformation, really kind of went from being practitioner driven, and doctors, physicians, clinicians to, having standards of care, having pathways of care. And if you think about the work we're doing at Gecko, it's not all that dissimilar. We're trying to understand the built world. We're trying to understand like what's going on, instead of the human body and inside of steel and concrete, and then creating pathways for the life cycle of an asset, which is, sometimes 50, 60, 80, 100 years for our most critical infrastructure. And so what's the best pathway to do that? So there's, much more we could dive into there, but that's just a little bit of the background on, a sector that I thought was really important. And one of the reasons why I decided that time was to move on, I kind of hit my ceiling there. I thought, was just very long cycles to make change, right? Healthcare doesn't exactly want to disrupt itself. 10 plus year cycles, FDA, and, just a lot of regulation. So the energy sector was another critical industry that kind of undergirded society. Something we all rely on. It is critical to our standards of living and just, our flourishing as a people. But I felt like more progress could be made there and just, a new environment for me to kind of expand my horizons.
I love the analogy of the human body with the human infrastructure that we have built. I think it's just spot on and mirrors a lot of my thinking actually around the built world, and we can dive into it a lot. But I'm really interested. There's this one question which I'm completely stealing from another podcaster that I love, but I would like to ask you, like, how would your teachers, looking back at Troy when you were in high school or in university, but it's cool to think about it in high school, how would they describe you?
Yeah. Well, I'll have to share who my first teacher was because she probably has only favorable things to say. It was my mom. My educational background is kind of interesting where, I went to preschool, like all good 3 and 4 year olds. And then what happened was I wanted to go into the next grade, and based upon the timing of the schooling district, I wasn't able to do that. So I was going to have to spend another year in preschool. And so my my parents decided we're going to homeschool him. And so they took me out and I went right into kindergarten. So I think my mom would probably have plenty of positive things to say about me. I'm her first child and all that. But uh, in all seriousness, I think my experience growing in this environment where, it's pretty unstructured. It wasn't like I sat in a class. It wasn't like I had, 9 to 5 kind of curriculum or 9 to 3 curriculum. I was very kind of self-taught, had to figure a lot of things out on my own. There was structure, of course, but I felt like it really taught me problem solving and taught me to, think for myself and have to just like work through
Yeah.
curriculum on my own. But I think, I went into public high school from there. And so that was like the ninth grade. And so what did the teacher say about me there? I was like, wow, this guy doesn't know how to document his work. And he's like all over the map and like he's figuring things out and he understands exactly the answer, but like can't talk about how I got there, because I kind of had this unorthodox background in schooling and I kind of conformed throughout my time in high school. And I think I, found myself being able to sit through a class of 40 minutes and, watch 5 to 6 kind of problems get solved in a group effort. And so I learned a lot of different things through that experience about how to work within teams and how to, document your work and things like that. But it's kind of frustrating in the first year of like, wait, this is the answer. Why are we spending 25 minutes trying to like, do a solve function? It's already in my head. So that was kind of interesting experience. One teacher had me come up, and I think I kind of earned teacher's pet at that moment, asked me to teach the grammar to the school, to the class. And because I was like, oh, that's a gerund, that's not a, whatever it was at the time. And so I was this kind of nerdy grammar kid.
Which is not the perfect recipe for a popular kid.
Yeah. I think I was quirky, right? I was a little quirky, but I played a lot of sports as well. So I was this like kind of jock
Oh, it
athlete. So
balanced it out.
I kind of tried to smooth out some of the roughness there.
And,
And then I
and
learned to
what?
just shut my mouth after that, right? No more volunteering that the teacher was wrong about gerunds.
You just let it go. But what were you passionate about? That was just beyond just school subjects.
Yeah, for me, I think I was always very much into just like exploring things. I'd always take things apart. That like, from a young age, whatever I was bought, any toy, I felt like instead of actually using it, I was figuring out how to like take it apart and put it back together. Oftentimes, it never got put back together.
Yeah.
I was very into like making things outdoors. Early ages through later in life, we just had a bunch of woods behind us, and so we explored. The whole neighborhood got together and really we spent a lot of time outdoors. I didn't remember video games. I didn't remember spending a lot of time indoors. I just remember all the neighborhood. When they got out of school and me by about noon, we would just play outside and have fun. In this wooded area behind us, building forts. Playing paintball, all the kind of stuff that kids would do. And then in high school, I think I took sports kind of semi seriously, academics a little less seriously. But I'd always been like playing 2 sports a season, and so I kind of never really focused on one singular sport. But in high school, I was, kind of bouncing between things like basketball, swimming, golf, and soccer is what I narrowed into. And eventually ended up when I went to college at Grove City. I continued on with golf, so that was something that I really kind of dedicated myself to through that time.
That's awesome. So a generalist by nature, one could say.
I think so. I've got a lot of interests.
Okay. Well, and that kind of explains why you would step. I mean, I get the analogy, right? We can draw that analogy post, looking backwards, but it's really interesting. I want to try to understand how do you. Well, first of all, when did you meet Jake, and when? Because I know you met Jake before founding Gecko,
Okay.
but I'd love to understand how was that process of deciding, hey, we should make a company that does, that makes robots that crawl on critical infrastructure. So how did that process come along? It doesn't seem like a natural, let's make a social networking app type of, startup choice.
Totally. Yeah, I think, similar to myself with Jake, we've always taken kind of like the unorthodox route or the hard path that others don't. And I think that makes us kind of have some resolve, some resilience, but also just like that uncertainty is exciting to us. And when Gecko started, I mean, it really was, people had a lot of things to say about why it wouldn't work or why it wouldn't succeed. It wasn't in the newsreels, what we do, protecting critical infrastructure wasn't something that people were thinking about a decade ago. Now they are. Now you can't not turn on the news and hear about some degrade infrastructure or some bridge collapsing or some pipeline leaking oil or some emissions that could have been controlled, right? So it's all in the news sphere, like it wasn't 10 years ago. So I think a lot of people thought we were pretty crazy for pursuing it, or it just wasn't a problem. Certainly the people on the inside didn't always necessarily like to admit that there was an issue here or something that needed to be solved. And I think that's commonplace, right? To say like, oh no, we're doing everything we can. There's not that sort of visionary deterministic thinking to say the world can be better. But you got to circling back to your question on like, how did we get together? It was 2011. I remember the day well. Like Grove City was only twice the size as my high school, and so it was, you got to know everyone. And I love that kind of feeling of like knowing everyone in the school. Always having all these like different groups of friends and in different pockets, and you go into the cafeteria. It's just like it's like what's going on versus going to one of the big state universities. And so Jake and I actually were in the Grove City version of a fraternity, and so we we're sort of like living on the same hall. We were never roommates, but we spent a lot of time together. Even though 2 years differed between us, I graduated in 2011. We actually met in 2010. So I graduated in 2011. He graduated in 2013. We met in 2010. And the whole inception behind Gecko actually came, it wasn't like a solution in search of a problem. It was a problem that presented itself. There was, a local merchant power plant, actually an alumni of Grove City College, where we were both attending, that was the power plant manager, in a county of 60,000 people called Oil City, PA, about, 40 minutes from our school. And this individual was trying to run a, full scale power plant and just having a, tough time doing it. Very reactive, not certain about the status of his equipment, younger guy in his career. So he was sort of kind of trying to say, what are the modern tools and technologies I can leverage? What's going on outside of my industry? And so, pretty cutting edge, thinker in that way, and just gave us access to the problem. I mean, the biggest thing that was deterministic to our success was just being able to firsthand experience that this is not something that could have been built in a lab. Robotics just don't come online and work in these purpose-built ways. And so, getting access to the environment, seeing a boiler that was, 40 foot wide by 60 foot long and, 150 foot tall, and just seeing that environment and say, wow, the state of the art is a human on a rope or a human on a scaffold with a single, point measurement tool. That's how they're trying to gather, the vulnerabilities or defects that are going to take them offline, costing, many millions of dollars every time that happens. That's all we got.
Yeah.
That really sort of highlighted for us the pain point. And, we started to look around and say, where else is this a problem? Is this just isolated to this one facility, or is this, kind of industry wide, multi-sector problem? And we found out it was. We found out that corrosion costs the world 3.5% of GDP, or $3.5 trillion a year is just spent on fighting corrosion.
And so it was a customer led type of discovery. You were like, hey, like, this is a hair on fire problem for you. We can probably make it, we can probably fix it. And who started the work on, so how did that timeline go? So you guys met with this gentleman that was running this power plant. And then when did you think that a robotic solution was the best? And then when did you get that first, prototype out? Was he the first person to benefit from Gecko's technology in the end?
Yeah, he actually he got the first iteration of the robot, and just to circle back on that, it was very much like a customer driven problem. But the important part was like there was a high amount of trust. Like we needed a co-development partner. We needed someone that was just kind of thinking way beyond the rest of the industry to even open it up, to give us the opportunity to test and iterate. Right. And so that robot went into his facility many times, failed many times. Right. And so that sort of feedback cycle and that iteration. So that was all back in like 2014, had the original prototype. that was used by him and helped, really solve a number of his critical problems. And that just became sort of the test bed to go full time on this. That was about the time that Jake quit his job, which was only a 1 year that he worked, for an automation company, and I joined him a year later.
Gotcha. Okay, that's awesome. I was front loading this to you at the beginning. So I'm looking at a lot of construction robotics, and the audience will hear a lot of stories on this podcast about robotics and the traditional industries in general. Because Gecko, I would not describe it as construction robotics. It's like robotics for traditional industries, robotics for inspection, and it's really really interesting for founders in the space to talk about that specific feedback cycle that first design partner allowed you to have. And I think this is something that basically it's a gatekeeper between the possibility of founding a company in the space and just the lack of resources to do so. How did that go? How did you manage expectations with the customer that in the end, probably, I don't know how much he was paying for that service. It could be nothing, it could be something, but he was expecting results. How did you manage that kind of like disappointment or not, initial clunkiness of the technology at the very beginning? And how did you extract learnings to then scale the products out of that?
Yeah. Yeah, it's a great question. So a couple things, one to touch on how do we set proper expectations with customers? How do we find the right customers to partner with? Because many of them wouldn't have been the right customers. So we needed individuals that, thought ahead of their time, but also understood and appreciated the stage that we were at. And, we always made sure they had skin in the game. There was no such thing as a free demo. We wanted to make sure that, and quite frankly, from a practicality standpoint, you don't get to just walk into these environments. You need terms and conditions. You need things in place because, God forbid something happens. Like there's a lot of potential, downstream impacts that could happen. So no one would just say, hey, come on site, do a free thing. And so actually to be under contract was useful to sort of set the standard of care and make sure both sides knew what they were delivering. And then I think on the business side of things and like how we thought about, okay, how do we get to the point where we have a robust product? Because we knew that at that time, especially things like, motors and gearboxes was either industrial grade or like hobbyist. It really wasn't in this sort of like intermediate stage that we're at, like a form factor of a, 30, 40, 50 pound robot. And so there was just a lot of components that were, suspect to failure right off the bat. And we're going to need design iterations. We're going to need us to actually build our own component parts and not be able to sort of just like integrate off the shelf. And, that's one of the things I think has advanced robotics in a lot of ways. There's a lot more, component parts and things that are built for these like purpose-built robots now that make the connector pieces a little bit easier, to leverage and to build technology at scale. But the key things for us was that we delivered a service, and that was, something that was, hard to determine in the moment to say, like, do we sell our robots or do we provide a service? And providing the service, although painful at times, spent many, many long 14-hour days inside of a boiler with hard hat and, the P100, kind of the thing that people were running around during the, the time of COVID, like in the healthcare sector, right? Like the thing that's going to not allow anything to come through. We were, wearing the hard steel-toed boots and the hard hats and getting, very close to the problem. And we delivered that service because it allowed us to internalize some of those issues. It allowed us to sort of smooth out the roughness in our product to the point where, and create that feedback loop to be able to iterate our robot about 10 times, throughout that like early 6-7 year period in the first act of the business. And like without that ability to rapidly, experience the problems firsthand and, design our way out of them, I think this is a big challenge, I think, for companies that have other business models where they just try to sell a hardware product to another, to an end customer or service provider, right? that's a challenging thing
Yeah.
to get that tech adoption even.
Yeah, so lots to unpack there. So I think the first thing you said, I think it's just common ground among just hardware founders. I don't think it's simply robotics. It's how do you get the right customers such that they are able to withstand the first iteration cycles, which are the most painful ones, the lowest ROI for them, and just product is clunky, operations are not streamlined, service isn't clear, the business model isn't clear. And then you also talked about how do we get a strong robot. So you were building this in 2012, 2013, if I'm correct, right?
Yep.
It's no, you know, Arduino and a Raspberry Pi time, I can imagine. It used to be more, either, as you said, either industrial grade, motors and actuators, or just very small, plasticky servos that you just cannot put on a robot. And you cannot spend 50K for a motor, but also you cannot go out to a customer with a low torque, easy to break, high failure rate motor. So I can see that you guys have navigated the hardest times. I think this today, it's the lowest of problems of robotics companies, just because the entire components industry has commoditized quality.
100%.
And so that is probably what surpassed. But what hasn't been surpassed is both the choice of the business model and the choice of the first customers. So you were talking about delivering a service, and one of the theses that I talk about a lot with my colleagues, and in general we talk about, is selling outcome as a service. So what were you selling at Gecko? Imagine me being your ICP back then, which might be a coal plant or anything that has to check their infrastructure regularly. What were you selling?
Yeah, and we were selling a offering that created clarity on the health of a critical asset, and it was really boilers. We focused very narrowly for the first 3 years on just power boilers. Again, sort of the surface areas were large. The environment was sort of, challenging to operate within. So, ruggedizing our robots. And then it just kind of started to expand outward from there. We started to focus on tanks and pressure vessels and, other geometries and other kind of even surface conditions to make sure that we didn't overfit the technology. But yeah, early days was we were selling data. No one. People thought the robot was cool, of course, and some people wanted to, have a video of them driving the robot. For the most part, they only really cared about what was that health map that we created at the end of the day.
So that health map, super interesting to understand that. So as I understand it, and I love to get to double click on it. What's the big difference? Actually, I love for you to explain to me, like, what is the big difference between having a dude on a rope rappel down from a large stand-up, tank of any kind, and take point measurements with classic ultrasonic testing? And for the benefit of the audience, like, ultrasonic testing is basically, tapping the tank hard enough that you can hear the spectrum and the sound waves reflecting within the water tank, and you can actually understand what's going on inside it and what's the structure thickness, how much has corrosion from from agents that are inside the tank, also outside, depleted the structural integrity of the structure. So I love to understand, what is the difference? Why is it a health map? How should I think about the unique value proposition of Gecko?
You're right. The underlying sensor is fairly similar. It's an acoustic signal, right?
Yeah.
Generated, measuring that sort of time that sound goes a distance. And we know the speed of sound in steel, or we know the speed of sound in other materials. So fundamentally, we leverage that same underlying sensor technology. But where it all becomes much more valuable is the data scale and the efficiency of gathering that data scale. So instead of one sensor with a human that's taking a reading, trying to interpret that signal in real time, translate that into something like maybe the thickness of the steel, or did they see some kind of anomaly in the signal, and that would be indicative of maybe a crack or some other kind of void. We're capturing, 50 readings per sensor every second, having a plurality of 32 sensors on a robot. So you're talking data scale of maybe 10,000 readings over a week versus 10 million readings in a day. And if you were to watch, if you were to look at like the most beautiful, artistic rendering, modern day or some impressionist, and you downsampled the amount of pixels or the amount of, points that they had those brush strokes to 0.01% of the picture, you wouldn't look at much. You wouldn't be able to decipher what was going on. It'd be a pretty poor experience. So that's the reality today. Is you cannot contextualize things if you're just taking a single point measurement. You have to see sort of the complete full picture.
So granularity of signal and ability to kind of like mesh all of this data into a actionable map of what's my asset actually looking like from the inside. That's what's making Gecko's service unique.
And not to mention that, and this is all kind of early day value prop, right? We'll talk about sort of act 2 of the business, but the other value prop was that we could do a lot of this while the asset was online. Elevated temperatures, elevated heights, confined spaces, without ever taking that asset offline. And a lot of times the human would need access to the inside. We're able to get all this information externally while the asset's still operating. So there's tremendous ROI for the customer in even just the gathering of the information, right? And sort of the ROI that they achieved. But the act 2 of the business is really the thing that's most critical, which is how do you take that information? How do you take that, static view of the health map of that asset and start to translate that in different dimensions, right? So there's sort of the longitudinal dimension. So what does this look like over time? And then there's the other dimension of how do I have this like constrained optimization problem around how do I align, sort of the long range financial planners, the operators, and the maintenance folks that today all make decisions in silos. And now I have, data that creates abundant clarity on options and, contextualize with other sources of information, such as, how long are we going to run this asset? Where did this asset start? What was the condition of this asset on day one? What's the condition of the asset now? What are my options to do sort of that life cycle management of the asset, right? And so that's sort of the extensibility of our software. And we have that advantage because we've scanned, tens of thousands of assets, right? We've seen these problems over and over again. And so there's the compounding value of the data too, that we come in with real insights around this is the best pathway for this asset. This is what we've seen based upon these environmental operating conditions, et cetera.
Super interesting. So the data network effects that this has been able to unlock just go beyond any human inspector that can have seen many of them and kind of acted on many of them with human judgment, but it just lacks the volume and just the sheer scale of the data throughput to make these actionable with such precision. And what is it that so I'm really interested in your customer experience and how you drive customer experiences. This is a really another complex problem for companies that are operating in the space. We're seeing this for companies that are operating in construction, in autonomous vehicles, autonomous equipment, and also testing. Mm-hmm. There's a customer that calls you up and needs a novel way to do their routine inspection of specific assets. What is the step of actions that the customer will see and the kind of like number of outcomes that it will see?
Yeah, so I think it's there's always that kind of person that's trying to fight a fire, right? And there's the sort of like I need this done today, right? And that often is smoke for a bigger fire for us. And you can bail that person out, make them look like a hero. We brought in a robot. We had no ability to take this asset offline or build all the requisite access for humans to come in on scaffold or ropes or whatever. And we got abundant data, right? Clarity. But the reality is that becomes sort of the stepping stone to get that organization out of reactive mode, right? Today, the built world largely operates based upon run it to failure, wait to see what breaks. It's very reactionary, right? And so we provide a pathway to, use our entire tech stack, robotics, with sensor data and AI, to give them the ability to be more thoughtful about what does the future look like, give and present options. And so, the sweet spot that we've heard from our customers is 5 years, right? They want to do a planning cycle in 5 years. They want to have anticipation on, this is what I should expect to, these are the trade-offs I might have to make in terms of runtime, production time, throughput, and the cost of sustaining this asset, right? We're talking largely about things that are in service right now, things that have already sort of been put into the built world. There's a whole nother aspect to this, which is, how do you build things, and create that baseline up front and ensure that assets come online as efficiently as possible. We could talk about some public sector work that we're doing there as well.
Super interesting. And yeah, that was going to be my next question. But before we jump on to understanding what is the appetite of the public sector, of the U.S. government and also foreign governments in general, for robotics and for automated inspections and just new ways of doing old things, I want to double click on manufacturing of the robots and try to understand, just even at a high level, how many assets do you currently own of your own robots?
Mm-hmm. Yeah, so the fleet is, fleet's pretty small but mighty, right? It's, we're somewhere between 50 and 100 robots,
Okay.
with 2 to 3 SKUs. So, yeah, I mean, and again, it comes back to that we sell a capability. The robots are a means to capture data, to create that workflow that makes the decision, that gives them the decision advantage. And so we don't
Nice.
need tens of thousands or hundreds of thousands of robots, right? Because these robots kind of go from place to place or get nested in a site. There's 5,000, kind of core industrial facilities just in the U.S. So it's like, that's kind of the upper bounds. Put a robot on
No,
every site.
and that's awesome. I think this is another cool thing of outcome as a service for robotics. You don't need to scale up the production to a level in which you're running into the risk of not being able, well, on one hand, of not being able to fulfill your demand, and on the other hand, to just bankrupt yourself by manufacturing. I think it's a great thing the outcome as a service provides is, I can always fine tune the number of robots that I have in my fleet, depending on demand. And if I need to increase my fleet, I can increase my fleet, but I don't have to necessarily. I can even run, the managerial decision of running a backlog and saying, hey, like, let's wait, let's just push this job 3 weeks down, just because it's better for manufacturing, because potentially all my robots are full. So I love that. So that's what I want to double click on. What is their greatest, or like what is the single greatest learning about manufacturing robotics that you can share?
I think that, for us, it kind of goes back to the, I don't know what's on the BOM, 5,000 components, right? It's a lot of components sourced from all over. COVID taught us a pretty painful lesson, which was, some of the chips, some of the microcontrollers, those things were, going to change. And what were we prepared to, have sort of, backwards compatibility, and, how do you maintain a fleet now that's getting this new component in? And so I think that's one of the things from a design, and manufacturing standpoint, is to have some redundancy, to have no single thread. It didn't affect us like the auto, manufacturers, or, with, the semiconductor, that were really reliant on the semiconductors. But we were not, we were not totally avoided that either.
Okay. So supply chain resilience is key in hardware, just because of the variance of the components. And actually, it's interesting because a lot of these robots, above all for robots that have to capture a lot of data, they just hold a lot of chips.
Hmm.
Every single sensor is a different chip, and specific if you want a specific granularity of the data, specific accuracy, you're going to need a specific sensor, and that specific sensor is probably going to be, done by two manufacturers in the entire world, and you've coded your entire software around that specific sensor. So you just cannot deviate without going back and changing the firmware. So I can imagine that that's a one of those cycles that can truly make or break
Yeah.
the product development. But and thank you for sharing that. I think it's super interesting. And so I think I saw, was it you or was it Jake in Congress?
Yes. Most recently, it was myself. I did a legislative hearing.
Okay. So, well, first of all, do you often wear a suit?
No, no. There was a period of time where I got rid of all my suits, so I've recently gotten back on the suit game. I was wearing one this past week too at a security forum.
Gotcha. So super interesting. We'll get the why, right? I think the question is going to lead us to why, but tell me the story of when did you first start your involvement with the public administration? What were your first public contracts? Where does the pain point in the public sector lie?
Hmm. Hmm. So 4 years ago, about to the date, decided to go after public sector, just seeing sort of the concentration of platforms, critical infrastructure, right? Our mandate as a company is to protect the critical infrastructure of the world and give form to tomorrow. And who better than the, DoD, Department of Defense, to have sort of that concentration of, critical platforms to protect. And so, it all started 4 years with the Air Force. They had a very sort of innovative kind of acquisition tool called AFWorks Open Topic. And basically what it allowed was a company like ours to come with a solution and say, we have a solution. We created this on the private sector. We are one of those dual use companies that you say you want more of. And we think this can help solve a range of problems. If you give us some money, we will go talk to hundreds of stakeholders and figure out who actually has the problem and how to connect it to, program dollars. Um, that's pretty atypical for the government. Typically, what they work with is large list of requirements. If you don't have all the, regulatory requirements, staffing,
Hmm.
with the clearances and, the accounting systems to comply with cost-based contracting and, the NIST security clearances, right? The list goes on and on. Then you're blocked out. So as a small business, good luck trying to go compete for any of those. And, let's be real, they're going to give them to the largest, most established players anyhow, because that's the de-risk thing to do, which the U.S. government public sector is really good at, doing. And so a lot of credit goes to AFWorks to creating this vehicle. There's now a number of other organizations that have followed suit with these sort of, more creative, non-traditional kind of contracting vehicles to do more than the cost plus kind of requirement based acquisition programs. And that just kind of one thing led to another for us. It just really started to snowball. We turned those into production contracts. We got involved with other arms of the service. We got involved with other agencies. And what we realized was very different than the private sector in terms of the how do you align interest and how do you, get all the stakeholders on the same page. But a big part of that is ensuring that what you're working on, is something that Congress cares about, and Congress appropriates all the money. So if you want, your solution to be, even be able to be obtained and bought by the government, you have to start beyond that mission. You have to start years ahead of time with Congress to plant those seeds and to build the advocacy for why this is a capability that the government should have.
And this is a very interesting insight. I think a lot of the companies, they're operating in this. I mean, we have seen, right, that defense tech wave that has come. I mean, one can call it, in and around the time that Anduril was,
Yeah.
coming into the
We're
market.
standing on the shoulders of giants with a few
Yeah,
startups that really paved the way for sure.
yeah, exactly. So these guys have paved the way, and also we have investors in, our friends that are
100%.
investing in these technologies, and huge shout out to them, because I think this is a great way for small businesses to break the ceiling into the incumbents. I think it's a specifically tough problem for defense tech when you have to stop five or six prime contractors in the United States that get appropriate something like 70% of the money
Hmm.
that is spent by these departments. Um, what did you have to change about your operations? What did you have to change about the way that you look at product development and product deployment when serving in governments? And also, I'm very interested. What are you, for whatever you can say, obviously, what are you serving the government for with Gecko's capabilities?
Yeah. So some of the things that are public that I can talk about is we're working a lot with the U.S. Navy around helping them get ships, surface ships, specifically classes like destroyers, frigates, out of dry dock more quickly. The amphibious class, which transports Marines around.
Okay.
Today, we can build a ship, but then you have to sustain it over its life cycle, and that 1/3 of the ships get out of dry dock on time. That means that there's a huge bottleneck waiting for this maintenance to happen to ensure that they're operationally ready, or they have the latest capability modernized to that platform. So there's a huge bottleneck in the dry docks with the surface fleet. But then there's the new build side of things, which is constantly upgrading your fleet, building things like strategic subs, new capabilities, and in the Constellation class frigates, and that is a different type of value prop, not totally dissimilar, but it's really about helping the suppliers, helping the industrial base make sure that they can put these platforms online as quickly as possible with the highest quality bar. And what we found is that a lot of things happen today where the QA/QC process waits till the end to find a problem, and then the rework that's associated with that is very painful. And so we can increase throughput for some of these suppliers by 50%, which in a time of not meeting our production needs for new builds is a tremendous value prop. And then if you think about it, it sort of rolls off very nicely into this sustainment, sort of data driven, condition based, predictive based maintenance platform, which is you already have this sort of initial instance. We have the rich asset model of the initial build, and so now we can just layer on all that context over its life cycle, and to help really plan thoughtfully around how to invest in that asset over the next 60 years.
Because these are assets that are really among the most expensive things that exist on Earth.
Mm-hmm.
Building ships, very large ships. You want to be investing in visibility on what's going on at a structural level there. Um,
And the
so
amount of suppliers, there's to build a strategic sub is about 5,000 suppliers, right? So there's a lot of pieces where you go back to your lowest common denominator in that supply chain.
super interesting. I love it. And so, what have you? In my question before, what have you changed? Because servicing,
Yeah.
power plants is one thing.
Yeah, the operations and the products. So, we are forward deployed we take a forward deployed approach. It's sort of evidence from day one. And, Jake and I wearing the hard hat, going to scrubgrass power generation and plant, all the way through till today. And so we set up, teams, deployment teams that are focused on that specific customer, that
Huh.
specific problem. And it's all leveraging the core architecture, the core platform we have. Things are built in a modular way on the hardware side and an extensible way on the software side. But the reality is like we have to understand the specific unique challenges of the customer, and to meet them where they are, and to ensure, even down to the levels of like, do our personnel have the right certifications, qualifications, etc. Every industry looks a little bit different.
And I'm about to ask you a weird question, but how do you how do you choose the people that lead the charge in the deployment teams? Because these are absolutely key people. If they screw up with the customer, you probably lost it forever. And
Mm,
and these are multi-million dollar contracts.
yes. Yep, sometimes hundreds of millions of dollars. So for us, we have, sort of like, to use two more generic terms, that, there is sort of a, an obsession of the problem, a sort of an alignment to like that mission. And there's a self-selection process to an extent there. But it's really sort of the intersection of how do you manage complex multidisciplinary projects that sort of span that gamut of operations to product, right? And what is the right capability to deliver? Um, and so it's understanding of, okay, how do we need to modify, augment the technology, and how is that in line with our roadmap, to also managing these kind of multi-stakeholder, we have real expectations. We're delivering a really big outcome for the customer. We need to stay in lockstep along the way. And so we have, functional areas that perform and fulfill those, but it's really an orchestration of that. And it becomes, at times a battle for resources internally, right? Like, let the best ideas, let the best opportunities win. And I think that's healthy for an organization to have some of that, healthy tension built in.
Super interesting. I remember, I believe it was, the Service Titan CEO that was saying something like, "You gotta choose a maniac to go lead every single charge when you deploy a new product." And I think it kind of matches what you just said. Like, the self-selection, your very political way of saying self-selection is, who's crazy enough that wants to, take the responsibility in their own backpack to go serve this $80 million contract. No, that's absolutely awesome.
And we have a concentration of, it takes more than one maniac to succeed on the mission. So they need a team of maniacs. But yeah, it's the maniacs of maniacs.
That's awesome. I think companies made the maniacs probably the ones that succeed the most. But on this, where the frictions that founders will need to go through and kind of like expect when they're building out these large deployments within within public administration customers? What type of frictions and in non-standard commercial practices and reaction will they have to expect?
Yeah, I think structurally it's just can be summed up in a few things. It's just like, how do you navigate bureaucracy? There's always three legs of the stool. It's not like a commercial customer that has budget, that has sort of the implementation, the decision making around that. It's like who you're selling to, who's the beneficiary, recipient of the capability versus who pays for it. Two different groups of people. You need to understand how to communicate with both. So yeah, I mean, there's aspects where we're blocked today, where we have a mission that wants this so bad, 3-star admirals pounding on the table, and we have a contracting office that just, can't get there because they don't have the resources. They're not motivated, and it's, it holds up. And so there's other ways to contract it, but it costs the Navy more, and it's just clunkier, and it's maybe not buying the exact capability that we want to be producing. And so there's, Peter Thiel, I think, summarizes it well, which is, he says you have to spend $1 billion to make $1 million, right? To make your first $1 million in public sector. And I think, if you look at our capital stack, we didn't raise quite a billion, and we've made more than $1 million, but there's some truth to it.
Yeah, no, I really share that view. I saw that specifically. So, I mean, we're already over time. I want to ask you, one last question. If you had to choose one piece of advice for founders in the build world, they're building hard stuff. It's going to take long to find. It's going to take long to get off the ground. It's going to take, real maniacs to lead the charge in their deployment. It's probably the hardest thing you can do. Above all, when 5.25% is the federal funds rate, right? And it's really hard to get capital. What would that be?
Yeah, just to compress that feedback cycle, to figure out who your customers are, and be totally radically prioritized to solving their problem. And sometimes you have to do things that don't feel like they're going to scale in hardware. And I think lean into that, embrace that.
Awesome. Yeah, no, great advice. And Troy, thank you so much for being here, for gifting me an hour of your time.
It was great to see you, Gabriele. Thanks for the
Yeah,
time.
likewise.
Awesome.
Then we'll speak super soon.
All right. Sounds
All
great.
right.
Talk to you soon.
Talk to you soon,
Take care.
Troy.